Today, we're going to analyze a simple problem that involves creating a multiplication table program based on user input. We'll walk through the logic step by step, breaking down how the program processes user input and outputs the multiplication results for a chosen number between 1 and 9. Step 1. The program flow. In the image, we see an outline of a simple program. It starts by asking the user to choose a number between 1 and 9. This number will be the one used to generate a multiplication table. Output. The prompt says, choose a number between 1 and 9. Step 2. Input and viable choices. After displaying the message, the program waits for the user to input their choice. The term viable choice in loop I means that the program will later check if the input is within a valid range, between 1 and 9. Input. The program accepts the user's input here. Step 3. Validating the input. Once the user inputs a number, the program will check if the number is between 1 and 9. This is crucial for preventing errors, as any number outside this range wouldn't make sense in the context of this program. Process. If the number is valid, the program continues. If it's invalid, i.e., less than 1 or greater than 9, the program stops or handles the invalid case. Step 4. Loop and calculation. Now, if the number is valid, the program proceeds to perform the multiplication. The program will multiply the user's choice by numbers ranging from 1 to 9. This is the loop I mentioned. Calculation. The multiplication process happens in this step. For example, if the user chose 3, the program would calculate 3 times 1, 3 times 2, and so on until 3 times 9. Step 5. Outputting results. Once the program performs the multiplication, it will print the result in a formatted way, showing both the chosen number and the result. Print output. For each multiplication, the result will look like this. 3 times 1 equals 3, 3 times 2 equals 6. This repeats until the final result, 3 times 9 equals 27, is printed. Step 6. Ending the program. After all the multiplications have been printed, the program ends. This is a basic program where the main goal is to show how loops and user input can be combined to generate a multiplication table. Conclusion. In summary, this program structure is designed to take a valid number from the user, check the input, perform the multiplication, and output the results in a neat and clear format. The key parts of the logic involve user input validation, looping for the multiplication, and handling different outcomes based on the user's input. Hello everyone. Today we're going to walk through a simple program analysis using a diagram. This diagram outlines the logic of a program that generates a multiplication table based on user input. The program is broken down into several steps, and we'll analyze each one to understand how it processes user input, performs calculations, and outputs the result. By the end of this explanation, you'll have a clearer understanding of how to create a basic multiplication program. Step 1. Start and initial output. Let's start with the first part of the diagram, where we see the word start. This simply represents the beginning of the program execution. The next line in the diagram asks, what? Logically speaking, which might seem a little confusing at first, but it essentially refers to the program prompting the user for input. After that, we see the first functional step. Output. Choose a number 1 to 9. This means the program will display a message to the user asking them to select a number between 1 and 9. This is the key input that the user will provide, and it will drive the rest of the program. Why this step is important? It establishes communication between the user and the program by clearly stating the user's expected action, choosing a number. Step 2. Viable choice and loop. Next, we have the step labeled Viable choice and loop I. Let's break this down. Viable choice refers to the program's task of checking whether the user has entered a valid number between 1 and 9. This is crucial because if the user inputs something outside of this range, the program wouldn't be able to process the multiplication table correctly. Loop I refers to a repetitive structure that we will use later to multiply the chosen number by values between 1 and 9. This loop is what allows us to produce a full multiplication table instead of just a single result. In short, this part of the diagram sets up two things: a check to ensure the user's input is valid, the structure to loop through numbers 1 to 9 to perform the multiplications. Step 3. Input choice. Moving on to the next step, we see input choice. This step represents the moment the program is waiting for the user to type in their number. For example, the user might enter the number 4. This will be the choice that the program uses to generate the multiplication table. Once the user enters a number, the program stores that input in memory, ready for the next step. Step 4. Process the input. Now we come to one of the most critical stages. Process if choice less than 1 or greater than 9. This part checks whether the user's input is valid. If the number is less than 1 or greater than 9, the program will terminate or provide an error message, indicated in the diagram by END, under step 6.1. However, if the user entered a valid number between 1 and 9, the program will move on to the next steps to perform the multiplication, which is outlined under step 6.2. Why is this important? Input validation is crucial in any program. If a user inputs something invalid, say the number 12 or the word apple, the program needs to handle that gracefully instead of crashing. Step 5. Loop and calculation. Now we come to the looping structure. The diagram shows if choice is between 1 to 9, which means the input is valid, the program continues to the next step. Calculate choice times I. Here's where the magic happens. The program takes the user's valid input, let's say the number 4, and starts multiplying it by numbers 1 through 9, one at a time. This process is called a loop, and it ensures that the calculation repeats until all products from 4 times 1 to 4 times 9 are computed. For instance, first, it calculates 4 times 1 equals 4. Then it calculates 4 times 2 equals 8. This continues all the way up to 4 times 9 equals 36. This loop structure is a key element in programming, and it's what allows us to avoid writing out every multiplication manually. Instead, we simply tell the program to repeat the same operation, multiplying, for different values of I. Step 6. Print output. Once the program has performed a multiplication, the next part of the diagram shows print out choice, I na result. This means that for every multiplication performed, the program will immediately print the result. For instance, after calculating 4 times 1 equals 4, it will print this result to the screen. It will continue printing results as it moves through each iteration of the loop, displaying each multiplication and result until the table is complete. The output for a user choosing the number 4 would look something like this. 4 times 1 equals 4, 4 times 2 equals 8, 4 times 3 equals 12, all the way up to 4 times 9 equals 36. This ensures that the user sees the full multiplication table for their chosen number. Step 7. End of program, 11 to 12. Finally, after all the calculations and results have been printed, the program reaches the step labeled End. This simply means that the program has finished its execution and has no more instructions to carry out. The program stops here. The diagram does a good job of outlining this simple process, from receiving user input to performing the multiplication, and finally, outputting the results. By walking through this diagram, we've covered input validation, looping through the multiplication process, displaying the results to the user. It's a great example of basic programming logic that you can apply to many other problems in the future.
Conclusion. In conclusion, this diagram provides a clear blueprint for creating a simple multiplication table program. We learned how to validate user input, use loops to perform repetitive tasks, and print out results in a readable format. This kind of problem analysis is essential when designing any program. Understanding the logic before jumping into coding is always a good practice. Thanks for following along.